Construct the indicated confidence interval for the population mean using the t-distribution. Assume the population is normally distributed. C equals 0.90, x bar equals 12.5, s equals 2.0, n equals 6. In this section, we're going to be using the t-distribution to construct our confidence intervals. The t-distribution looks very similar to a normal distribution, however there are some small differences. You can also look on page 310 of your textbook for a definition and an outline of what the t-distribution is. One major difference between the t-distribution and the normal distribution is the use of degrees of freedom. The degrees of freedom is the number of free choices left after a sample statistic such as the mean is calculated. And we calculate the degrees of freedom by calculating n minus 1. So in this case, n minus 1 would be equal to 5. Now let's list out the formula for the margin of error using the t-distribution. You'll notice that it's very similar to using the standard normal curve, but there's one small difference, and that's we're going to use a t critical value. Now let's look at the t-distribution real quick, and let's figure out how we can find the t critical value. This is your t-distribution table, and this is specifically table 5. If you look in the back of your textbook, you can find this table. Now notice up here that we have the level of confidence listed at the top. So when we're looking for the level of confidence, that t critical value, we'll use those to help us find the t value that we need. And notice here that we have our degrees of freedom. Now let's calculate the critical value that we need for this particular problem. In this problem, our confidence interval is 0.90, and our degrees of freedom we calculated was 5. So I'm going to find my confidence interval of 90 and my degrees of freedom of 5. So where these two intersect is going to be the t critical value, and that's 2.015. Now let's take that critical value and let's put it back into our formula. So here we said our critical value was 2.015, our standard deviation is 2.0, and n is 6. 2.0 divided by the square root of 6 is approximately equal to 0.816. This is approximately equal to 1.6452, and I'm going to round this to the nearest tenth, since in my problem x bar is rounded to the nearest tenth. Now to get the confidence interval, I'm going to take x bar minus the margin of error, x bar plus the margin of error. So this is going to yield 12.5 minus 1.6, 12.5 plus 1.6. And finally, that would yield the confidence interval of 10.9, 14.1.